So when we see the letters GCF, that stands for the greatest common factor. So we talked about factors a little bit earlier this week. So a factor, remember, is a number that we're going to multiply together in order to create a product. And if we're looking for the greatest common factor, what we're really looking for is we're looking for the largest or the greatest number that can divide evenly into two different numbers. So we're looking for what's the largest factor that they both have in common. LCM stands for least common multiple. So a multiple, remember, that was like when we were skip counting by a number. So multiples of 6 would be 6, 12, 18, 24, 30, 36, and I could keep going. So the least common multiple, that's when we're looking for the smallest number that is a multiple of two different numbers. So there are two different ways mainly that we can find GCFs and LCMs. I'm going to show you both ways and you can pick whichever one is your favorite. The first one is using a Venn diagram. Okay, a Venn diagram, remember, has two circles. So 1, 2. And where they overlap, where they overlap, that's what shows what they have in common. So if I was trying to find the GCF and the LCM of the numbers 12 and 30, I have my Venn diagram drawn right here. I'm going to make the left side 12 and the right side 30. You could switch them if you wanted to, but I did that because 12 is already on the left side, 30 is already on the right side here. So when you are doing your GCF and your LCM Venn diagram, what we're going to do is we're going to practice our prime factorization, which by building our factor trees. What we're looking for is all of the prime factors. So 12, I can split up into 6 and 2. 6 is not a prime number, but 2 is, so I'm going to circle it. 6 can be split up into 3 and 2, which are both prime numbers. So when I write this out, I'm going to write the expanded prime factorization. I'm not going to use exponents, and you'll see why in a second. So I would write the prime factorization of 12 as 2 times 2 times 3. I'm going to do the same thing with 30. I can break 30 into 3 and 10. 3 is a prime number, so I'm going to circle it. 10 is composite, so I can break that one down into 5 and 2, which are both prime numbers. So I'm going to write that expanded prime factorization. So this would be 2 times 3 times 5. So now I'm going to use these prime factors to fill in my Venn diagram. So I see that 12 and 30, they both have 1, 2 in common. So I'm going to cross a 2 off from both, and I'm going to put that 2 in the center of my Venn diagram because, again, that's where the Venn diagram shows what the two sides have in common. 12 has a 2, but 30 doesn't have another one that they have in common. 12 has a 3, and so does 30. So I'm going to cross those off, put it in the center of my Venn diagram. And then what is left over, so for example, 12 still has another prime factor of 2 that 30 does not have. So that 2 is going to go only on the 12 side. And then 30 has a prime factor of 5 that 12 does not have. So that 5 is going to go on the 30 side. So they have a 2 and a 3 in common. 12 has another 2. 30 has a 5. So when you do the greatest common factor, you're going to look at the center part. So whatever is in the middle, which is 2 and 3, you're going to multiply those two numbers together in order to find your GCF. So 2 times 3 would give me 6. Which means 12 and 30, their greatest factor that they have in common would be the number 6. To find the least common multiple, you're going to start by taking the GCF, which is 6, and then you're going to multiply it by whatever is on the left side, so that would be a 2, and by whatever is on the right side, and that would be a 5. So 6 times 2 would give me 12, times 5 would give me 60. So 12 and 30, their least common multiple is 60. And if I were to write out their multiples, it would be 12, 24, 36, 48, 60, 30 would be 30, 60. So sure enough, that is the first place they have something in common. Okay, we're going to do another problem, but I'm going to show you the other way that you can do GCF and LCM. So I have the two numbers 54 and 45. So this is called the ladder method. So I'm going to rewrite those numbers, so 54, 45, and I'm going to put an L around them, a really long L, but it's an L. Okay, what I'm looking for is I'm looking for some number right here that they are both divisible by. So I see in the numbers 54 and 45, 2 is not going to be an option because 45 is an odd number. 3 is going to be an option because 5 plus 4 gives me 9, 4 plus 5 gives me 9. So I know they both have 3 in common. So I'm going to write the number 3 to the bottom left. I'm going to draw another part of my ladder. But this time, I'm going to go ahead and divide 54 by 3. And whatever that quotient is, I'm going to rewrite it under the number 54. So 54 divided by 3 is 18. And then I'm going to do the same thing with 45. I'm going to go ahead and divide it by 3. So 45 divided by 3 would give me 15. So now the two numbers that I'm dealing with are the numbers 18 and 15. And again, I'm going to see what they have in common. So I'm going to draw another ladder. Again, 2 is not going to work because 15 is an odd number. But I see again, they have 3 in common. 1 plus 8 gives me 9. 1 plus 5 gives me 6. So 3 is another option. 18 divided by 3 is going to give me 6. And 15 divided by 3 is going to give me 5. So now when I look at my two numbers that I have remaining, 6 is a composite number. I could keep breaking it down, but 5 is a prime number. I can't make it any smaller. And 5 will not go into 6. So this is where my ladder stops. 6 and 5, they no longer have anything in common. I can't break them down any smaller. So to find the GCF using this method, I'm going to look at over here on the ladder, the things that they had in common. So they had 2 3s in common. So that would be 3 times 3, which would give me 9. Their greatest common factor was 9. To find the least common multiple, again, I'm going to take the greatest common factor, which was 9. And now I'm going to bring in the two numbers that I just couldn't break down any further. They didn't have anything in common. So it would be the number 6 and 5. So if I do my multiplication, I know I'm going to go out of order here because remember that commutative property says that we can multiply in whatever order we want. So 6 times 5 is going to give me 30. And then I know that 30 times 9 is going to give me 270. So the least common multiple of 54 and 45 would be the number 270. Okay, I'm going to do this last one both ways, just so you can see it both ways. And again, you get to pick whichever way you like best. Both should get you the correct answer. So I'll start with the Venn diagram. So I need to break down 72 and 90. So I know that 72 I can break down into 12 and 6, both of which are composite numbers. So I'm going to keep breaking down. 12 can get broken down into 3 and 4. 3 is a prime number, so I'm going to circle it. 4 is a composite, so I got to break it down into 2 and 2, both of which are prime numbers. 6 can be broken down into 3 and 2, both of which are prime numbers. So if I write out the expanded form of the prime factorization, this would be 2 times 2 times 2 times 3 times 3. So 2, 2, 2, 3, 3. Let's break down 90. 90 can get broken down into 9 and 10, both of which are composite numbers. 9 can get broken down into 3 and 3, which are prime numbers, so I'm going to circle them. 10 can get broken down into 5 and 2, which are both prime numbers, so I circle them. So my prime factors, or excuse me, my expanded prime factorization would be 2 times 3 times 3 times 5. So I'm going to build my Venn diagram. Again, just because of the way the problem is set up, I'm going to keep 72 on the left, 90 on the right. So to start off, they both have 1, 2 in common. So I'm going to scratch it out from both sides, put that 2 in the middle. 72 has another 2, but 90 does not. So the rest of the 2's, which is 1, 2 2's, belong just on the 72 side. Then I see that they have a 3 in common. So I'm going to cross off a 3. I'm going to write it in the middle. I see that they have another 3 in common. So I'm going to cross off those 3s, write it in the middle. And then 90 has a 5 that it keeps all for itself. So if I were going to do the GCF, I'm going to take everything right here in the middle. So that would be 2 times 3 times 3. So 2 times 3 gives me 6, times 3 gives me 18. The least common multiple, again, I'm going to take the GCF, so I'm going to start with 18. I'm going to multiply it by what's on the left side, so that would be 4. And I'm going to multiply it by what's on the right side, that would be 5. So again, I'm going to work a little bit backwards because the commutative property lets me. I know that 4 times 5 is going to give me 20, and 20 times 18 is going to give me 360. And I'll do the ladder method as well so we can see how it works both ways. So here's 72, here's 90. I'm going to draw that first ladder. Okay, when I look at this, I see that they actually both have a 3 in common. 7 plus 2 is going to give me 9. So I'm going to pull out that 3. I know that 3 is going to go into 72 a total of 24 times. 3 goes into 90 a total of 30 times. I'm going to pull out another factor because 24 and 30 are both composite numbers. So I've right off the bat see that they have 6 in common. Maybe you saw that they have 2 in common. Again, lots of different ways to do it. You're just looking for things that those numbers have in common. So I saw 6. So I know that 24 divided by 6 is going to give me 4. 30 divided by 6 is going to give me 5. And then 4 and 5. 5 again is a prime number. It's not a factor of 4, so this is where my ladder stops. So if I were going to solve for GCF, again, I'm taking those numbers on the left side. So this would be 3 times 6, which sure enough still gives me 18. Everything matches. And again, I'm going to take that GCF, which is 18, and I'm going to multiply it by what's on that bottom step of my ladder. So 4 and 5. Which matches exactly what I have over here from my Venn diagram. So I do get a final answer of 360.